Hello everyone, this is Jesse Carey and welcome to my demonstration of the work I did to complete this operator report project. Let's start with the README file, which you can find here in the root. It is a markdown file, so I suggest for readability copying and pasting the contents into a markdown editor or viewer. I've already done this, so let's go check that out. I'm using stackedit.io, and here is the formatted README. I won't go through the entire thing, but I will point out a few things. There are some prerequisites that you will need to run this project. You will need Microsoft .NET Core Framework, Microsoft SQL Server, and Microsoft Azure Data Studio. Just to note that all of the development that I did for this project was on Ubuntu Linux, so I have included links and instructions here for both Windows and Ubuntu Linux. If you're running Windows, I included some links to download and install the tools that you'll need. If you want to get a little funky and run this on Linux, go ahead and follow these instructions here. These are the same instructions that I used to get this up and running on my development machine. SQL Server does not run on Linux, so you will need to find a workaround, and the particular workaround that I chose was to run the database in Amazon's RDS. So when you run this project, it is already set up to connect to my database in the Amazon cloud. If you choose to run this locally, run Microsoft SQL Server locally, you can do that, and I will cover the instructions that you need to follow to do that as well. Here's some simple setup instructions for creating the chat user and giving them ownership access to the chat database, and some usage instructions on how to run the project once you have everything set up. And then finally, I do have some notes regarding the use of a local Microsoft SQL Server installation versus an AWS hosted database. So the first thing you will need to do is grab the contents of dbscript.sql, which is also found in the root. You will need to copy and paste this entire file into Azure Data Studio and run it. You'll notice here that I've commented out some lines. The purpose of that is that I am running this in the Amazon cloud, not locally, so I do not need to create the local database and log files. After you run this script, you will have the database created, the data input into the database, and you will have a stored procedure. According to the README file, the next step you must do is create the chat user and give them ownership over the chat database. So if you run these lines here, you will now have a user called chat with a password of chat with ownership over the chat database. Now let's take a look at the stored procedure. This is where it gets fun. Here is the original stored procedure provided with the project, which has some errors in it. The first error I noticed is a division by 0. So if we go ahead and select the query of this procedure and try to run it, on the chat database, you will notice that there is a divide by zero error. So let's take a look at what's going on there. We have a bunch of subqueries inside this stored procedure. One of them performs a division. The denominator of that division operation is sometimes 0, which is what resulted in this divide by 0 error. It has to do with calculating the reactive response rate. And the first thing I noticed is that the proactive response rate did not throw any errors. The reason for that is there is a check here to make sure that the denominator is greater than 0. So one way to fix the reactive response rate would be to include a similar check to make sure that the denominator never equals 0, or if it does, then handle that error. But that's not the route I took. So let me get back to that in a couple of minutes, and I will go over a few other things that I noticed with this stored procedure. There are a lot of duplicated queries in here, specifically with regard to calculating the response rates. For example, this query here has already been performed. This query here has already been performed. And this query here has already been performed. That's a lot of duplicated operations going on in this stored procedure, and that is the first thing that I decided to tackle. So now let's take a look at my modified stored procedure. This is the stored procedure that you will find in the SQL script file included with the project. First, notice that I am doing a query of queries. Here's the main query, and here is the query of that query. That isn't necessary for the way that I have this set up, but I did include it just as an example of different ways that you could handle calculating the response rates. Notice here that I have commented out the proactive response rate and the reactive response rate. Let me fix that real quick. The purpose of doing it this way is to remove those duplicated queries. I've already run this query one time. It doesn't need to be done again if I use this method of selecting from a query of queries, as I like to call it. You have already selected the numerator and denominator for both the proactive and the reactive statistics. There's no need to run those same queries again if you follow this paradigm of a query of queries. You can simply do your division by 0 check, then do the calculation, and of course multiply it by 100. However, I also decided not to follow this approach and decided to move the rate calculations out of this stored procedure and into the application. I will get to that later as well. One other thing I'd like to point out is that I found two ways to determine who initiated the conversation, whether it was the operator or the visitor. So I've included a few queries in here that are commented out that use a partition by operation with a row number function to figure out who initiated this conversation. I don't know if this query or this query runs faster. The amount of data in this database is too small to really run any tests to determine which of those queries would run faster. On a larger set of data, we might be able to determine that one of these methods is faster than the other. However, one thing I'd like to note is that if we included an additional column in the conversation table called initiator, and that column contained the data either operator or visitor, then we could greatly simplify this stored procedure. Notice that these stored procedures have a lot of subqueries going on, which is extra taxing on the database, uses up more resources. And the whole point of these subqueries is to determine who initiated the conversation. If we were to include an initiator column in the conversation table, we could avoid a lot of that extra work done in this stored procedure when determining who initiated a conversation. Now let's move over to the project code. Here's the controller. Here are just some simple actions for displaying the index, about, and contact pages. The contact page is empty. I did not create a contact form. But let's get down to the actual report page. I'm using the same URL for both displaying the report and for accepting form inputs for filtering that report. So I've included both the HTTP GET and HTTP POST callouts here, which the router will use to execute this action, regardless of whether you are getting the report or posting filter data to the report. There were a couple of errors in the original code regarding the object instantiation, which I've corrected here. The next thing I do is accept the form inputs from the post when you are filtering the report. I am building up the stored procedure execution string here, starting with the base execute dbo.operator productivity. And then I will add to that, if you have decided to filter the report, certain parameters. Those parameters are passed on to the stored procedure through these arguments. Here we are accepting the website filter. Here we are accepting the device filter. And since both of those come from drop-down menus, I'm not doing any server-side validation. However, the date range filter does have the option to free type in some dates. And to prevent server errors, I'm doing some very simple server-side validation of those dates. The only purpose of this is to prevent server errors. It could be expanded to include things, for instance, is the to date greater than the from date? Currently it does not do that, but that would be a nice feature to add. The next thing we do is remove the trailing comma from the stored procedure query string. The purpose of that is every time I add a parameter to the query string, I include a comma at the end of it. However, if you have a comma at the very end of your query execution string, the database will throw an error. So this line here checks to see if the last character in the string is a comma, and if it is, remove it. The next thing we do is create a connection to the database and run the query. Now we're going to read the rows being returned by the database. One thing I've decided to do here is run the response rate calculations. So again, going back to our modified stored procedure here, instead of running that calculation here in the stored procedure itself, I'm going to run those calculations here inside the application. Then we input all of that data one row at a time into an object, and then add that object to a collection. The next steps we need to do are handle the website and device filters. So we'll run a query to grab all of the distinct websites from the conversation table and store them in a list, and do the same for the devices from the visitor table. Now let's move on to the updates I made to the model. Not a lot of updates here. However, I did add a website class and a device class. One thing I did not do, which I could, is follow the same paradigm that we have for the actual report data. Instead of creating the website and device lists here, like we are creating the data list, I'm creating those lists in the controller. Now let's take a look at the view. The first section here is a set of radio buttons to switch between using a drop-down of predefined date ranges, or allowing you to enter custom date ranges. The next section here is the form used for filtering. You'll notice that we have a drop-down for websites, a drop-down for device name, and then a few hidden fields for the date range. The next section we have here is the actual drop-down for the predefined date ranges. I decided to use data attributes, data from, and data to for each of the options. The next section we have are the custom date range options. These are simple text input fields in which you can free type any date you wish. And I've also attached a jQuery-based date picker to each of those. The next section is the table itself. Obviously, we have the headers. And then as we loop through the data that was passed from the controller, I do a little bit of formatting on the chat length columns, and then print out a row of the table. And finally, we have some jQuery to handle the filter inputs. This first section here allows us to use the radio buttons to toggle between the predefined date ranges and the custom date range fields. This next section is a listener that looks for a change on the predefined date dropdown. When a change is detected, it grabs the from date, the to date, and the value. The value is either today, yesterday, last week, this week, etc. It adds those values to the hidden form fields, and then submits the form. Likewise, we have a similar section here that handles the custom date ranges. And again, we'll submit the form. This next section here listens for changes on the website filter or the device filter dropdowns. And again, submits the form. This last piece of jQuery here simply adds the date picker plugin to the free type custom date range fields. Now let's run this project and see what it looks like. The first thing you will need to do is change directories to the operator report subdirectory. Then you will need to run a .NET restore. A .NET clean. And a .NET run. At this point, .NET will fire up a web server and give you an address in which you can view your project in a web browser. So let's take a look. Now you'll notice that this is not secure, and I'm getting a warning from my browser because this is an HTTPS address. So the first time you run this, your browser will probably give you a warning saying that it's a secure address, but there's no SSL certificate installed. At that point, go ahead and just allow your browser access to this page. Since it's localhost, you should be safe in doing so. Just think about that whenever you see your browser give you that message. And if you're anywhere on the web, I would suggest clicking the link that says, "Take me to a safe website." I've included on the About page some notes and a list of updates that I would make to this project if given more time. Go ahead and read through those. Now let's take a look at the actual report. All of the styling on this site has been done with Bootstrap. And I've also included a Bootstrap Select plugin, which allowed me to style these three drop-downs. So these are not native HTML drop-downs, they are Bootstrap styled. Let's go ahead and check out how they work. So if you wanted to see all of the data from only the Gucci site, you would click Gucci. And notice that I don't have to submit anything. There's no buttons to click, no submit buttons to click to allow that action to take place. It happens as soon as you select a different filter option. Same with devices. And notice how the data changes as we select different options. Now let's take a look at the predefined date filter. We have today, yesterday, this week, last week, this month, last month, this year, and last year. Unfortunately, all of the data in the sample database is from March of 2017. So none of these filters will return any data. Let's take a look at last year. You'll notice that the data is empty. However, knowing that all of the data is from March of 2017, we can use the custom date filter. Now these are radio buttons. However, I used some built-in Bootstrap styling to display those radio buttons as standard buttons instead of radio buttons. So in the custom date filter, let's go ahead and select last year. Okay, we've already done that. Oh, I forgot, now it's 2020. So if we change this to 2017 March and do the same here. You'll notice there is a little bug here with the date selector that I have noted on my About page. Sometimes it works and sometimes it doesn't. That is one thing that if I had more time, I would investigate and fix possibly choosing a different date selector plugin. It did it again. Like I said, sometimes this works fine and sometimes it doesn't. I'm going to refresh the page. Sometimes that seems to help with this date selector. And let's just go ahead and use the date selector. March 1st, 2017. To March 31st, 2017. Click Go. And now you will see the data reappears. If we select all sites and all devices, you'll see that the data, all of the data is now included. Let's go ahead and shorten this window a little bit. Say the 1st of the month to the 15th. And you'll notice that the data changes because now it is only including half of the month. Let's go ahead and try the free type version again, and hopefully we will not run into the same bugs that we were running into before. Let's change this to the 14th. Through the 31st. (2017). Well, it did it again. Looks like I have a bug to fix. Let me see if I can fix that before I submit this project to you. But at this point, I think I will conclude my demonstration and hand everything off to you guys. Thanks for listening.